Assalamu alaikum everyone, hope you're all fine. Welcome back to my channel, and today we are going to discuss the computer science 9618 paper 1, and the topic is the system software. This is one very important chapter in your theory paper, and today we are going to see and we will discuss why a computer system requires an operating system, and explain the key management tasks carried out by the operating system. We'll discuss these management tasks, like we'll talk about the memory management, file management, security management, hardware management, and the process management. So let's start. The very first thing that we all need to consider is that why a computer system require an operating system. So this is one very important question, and we will first look into it. And the operating system, why a computer system require an operating system? This question actually needs us to go back and look how the computers they were working. Like in 1970s, the home computer was becoming increasingly popular. All right, and such as the Acorn BBC-B, an internal ROM chip to store part of the operating system. There was an internal ROM chip which was used to store some part of the operating system. All right. A cassette tape machine was also used to load the remainder of the operational software. So the softwares which were remaining, they were to add by using the cassettes one after the another. This was necessary to get the computer started, and used a welcome cassette tape which had to be used each time the computer was turned on. So this was the way the computers were started. They run the program and the ROM chip and the magnetic tapes, the cassette tapes, they were used. And when the hard drive was developed, operating systems were then stored on the hard drive. And the startup of the motherboard was handled by the BIOS setup. So this was the first very important thing that came when the hard disk drive was developed. So there was a basic input and output system that played a role to start up the computer. And initially this BIOS was stored on the ROM chip, but in the modern computer now they are stored on the flash memory chip. This is something which is new in our latest computers. The BIOS configuration is stored in the CMOS memory, which means it can be altered or deleted as required. So that is the EEPROM, electrically erasable programmable read-only memory. So now these are the latest things. So the BIOS memory can also be altered by the user. The required part of the operating system is copied into the RAM when the computer starts working. And since the operating systems are now so large, so it is not required that whole operating system is loaded into the computer. Rather, the part of the operating system is loaded into the RAM. So these are few things that is necessary to understand the role of the operating system. That before the hard drives, how the computers they were started, how the programs they were run, and there were the use of magnetic tape, the cassettes, the ROM, and the starting up and the welcome message, they were written like that. Okay. So with the advent of the RAM, with the advent of the hard drive, and with the advent of the ROM, the BIOS, all these things, the operating system now has one very important role in the functioning of the computer. Without the operating system, no one can just think of using the computer. It's just like a dump machine. So what the operating system is doing, operating system is, it provides basically an environment in which the applications can run and a usable interface between humans and the computer. So the humans, they interact with the computer due to this OS. This is the interface. So the interface works to let the user interact with the computer. The operating system also disguises the complexity of the hardware. So you don't need to look into the different complicated things. You just select the option, you just give a click, and the things, they are done automatically. And the operating system we are using these days are the Windows, Apple Mac, and then Google Android and iOS, Apple mobile phones and tablets. So these are the operating system that we are using. And more importantly, that how when this operating system is being used, the user, when we are interacting with the computer, so the user is interacting with the help of HCI, the human computer interface. And this HCI is actually a graphical user interface, GUIs, nowadays. So there are two ways in which the user can give instructions. All right. See, so the methods. The HCI has this HCI is either through the GUI or through the CLI. So this is graphical user interface, or this is the command line interface. So either the the user is interacting with the help of the icons, user is interacting or giving commands or instruction with the help of the buttons, the menus, the pull down menus, the pop-up menus, and or there is another way, more direct way, more complicated way rather, I will say, is with the help of the CLI command, where you are writing the commands on the screen, and every command is instructing to perform an action like dir, and with the help of the switches like \p, so page wise. So there were many commands we were to learn when there was no GUI to interact with the computer. So these two ways are there to interact with the computers. One is the HCI, one is the GUI, and the other one is the CLI. Now coming toward the more important part, the tasks. The task which is very important, operating system task, and these tasks are: number one, memory management, security management, process management, hardware management, and file management. So these are the tasks that the operating system is doing for us, for our computers. Memory management, you know, is an important responsibility of the operating system. You all know that the microprocessor, when it does the work of fetch, decode, execute, all the programs which are running, they are loaded into the RAM, and they are loaded into the RAM from hard disk drive or the storages. So first the program or the part of the program will be loaded into the RAM, and then it is available to the CPU for its functioning, for its processing. So memory management is important because whatever is being loaded into this RAM, this one, its proper management and the allocation of the space into the memory. So that is the one very important role of the operating system. So first is the memory management that we have seen as one important role, number one. So memory management requires three important part. इस memory management में हमें तीन काम करने पड़ते हैं. One is memory optimization, means कि operating system को करने पड़ते हैं. One is optimization, the second is memory organization, and third is memory protection. इन तीन methods के ज़रिए से, इन तीन की responsibility के ज़रिए से the memory management task is accomplished. Memory optimization, जैसा कि मैं अभी बता रहा था कि memory optimization is used to determine how computer memory is allocated and deallocated. आपको पता है कि I told you that जिस भी प्रोग्राम ने प्रोसेस होना है, रन करना है, उसे मेन मेमोरी में लोड होना पड़ेगा. इट हैज़ टू कम इन द मेन मेमोरी. और जब वो मेन मेमोरी में आ रहा है तो फिर वो कहाँ से आ रहा है? इट इज़ कमिंग फ्रॉम द सेकेंडरी मेमोरी इनटू द मेन मेमोरी. सेकेंडरी मेमोरी से आप उसको मेन मेमोरी में लेकर आ रहे हैं. एंड वंस इट इज़ लोडेड इनटू द मेन मेमोरी, और ये वहाँ रहेगा until it is used or it is being processed, and definitely once its task is over it will be taken back to the secondary memory. तो memory optimization में allocation and deallocation of the memory among various application is done simultaneously. ठीक है? And it also determines where they are stored in the memory. Memory में भी उसको कौन सी जगह दी जाएगी? The programs, the running program. अच्छा, एक बात याद रखें कि a program in the hard disk drive, when it is loaded into the memory, it is called a process. Okay? तो जब program process बनता है, means it is running, तो उसको कौन सी जगह दी जाएगी? And then after allocating the space to the process, keeping track of all the allocated memory and the free memory available, so that the operating system can decide that further how much memory can be allocated to the requesting applications. So basically this is the job under the memory optimization, that to maintain optimization of the memory and by swapping the data to and from the hard disk drive or SSD. Then next is the memory organization. In the memory organization, it determines, in this job is the determination of how much memory is allocated to an application. When an application is loaded into the memory, तो उस application को कितनी space provide की जाएगी? How much space will be provided to that application? And how the memory can be split up in the most appropriate or efficient manner. Efficient approach क्या होगी so that the memory can be distributed? अब इस purpose के लिए this can be done with the use of a single partition allocation or a partitioned allocation. यानी contiguous allocation है जहाँ पे complete part of memory is allocated and then there is a partitioned allocation. इस चीज़ को हम डिटेल से आगे देखते हैं. In the partitioned memory organization, a single contiguous allocation, all memory where all of the memory is made available to a single application. Okay, this is used by MS-DOS and by the embedded systems. यानी आप देखें, like in this example, if you see here, these are the block of the memory 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like a file abc.txt is allocated memory, so it will have the memory from 0 to 3. So 0, 1, 2, these are allocated to, these blocks are allocated to, and this is the complete need of this file or this process or program. So after this, another video is being run. So it will be allocated the memory from 4, and the length is 4 and 5, two blocks. Then another which is from 9, and it is assigned 3 blocks. So the memory will be allocated to the running application based on its need. As much as the process requires the memory, it will be allocated. So it is totally related with the requirement of that application. So that is the single contiguous allocation. So another way is the second method is the partitioned application. All right. Partitioned application, where the memory is split up into contiguous partitions, and memory management then allocates a partition, so you have an equal distribution. So we further have two ways in it, one is paged memory and the other one is segmented memory. But the thing is that the memory is distributed among different partitions, and then whenever an application requires the allocation of the memory, that partition will be allocated to that application. So when it is the paged memory, this is the partitioned allocation in which each partition is of a fixed size. I will show you in the diagram that this is the fixed partition in which you can see that 8 MB, 8 MB, all the partitions, they are of same type. So whenever an application requires a memory, so in the memory it may be given 2 chunk, 1 chunk, or can be 3 or 4 chunk, but definitely they will get equal size of chunk. But on the other side, the variable partitioning, the memory is provided as per the requirement, that is the variable partition. So paged memory is the partitioned allocation, but each partition is of fixed size, and the segmented memory is different because memory blocks are not contiguous. Each segment of the memory will be logical grouping of data, means this is possible that a process, let's say, requires 2 parts, and one piece will be given space here and another piece might be given the space after 2-3 partition. So the allocation of the space is not contiguous, it is scattered, it is distributed based on the availability of the space. All right. The next important responsibility is the partition memory protection. Memory protection is when two competing applications, they are requesting the space in the memory, and the operating system will not give them the same space at the same time. If this is not done, what will happen? The data can be lost, application could produce incorrect result, and the computer may crash. Memory protection and memory organizations are different aspects of the operating system. Operating system may use a typical type of memory organization, for example, paging and segmentation, but it is always important that no two applications can occupy the same part of the memory. This is the main responsibility. Now you can see that how this memory protection is done. This is the address and this is the memory operating system, like it is given the space from 0 to A, and now there is a boundary location, that is A plus 1, and another application when is being allocated the memory, so it will be from A plus 1 till B, and then the next application comes, it will be given the space from B1 plus till C, and if another application comes, then C plus till Z. So this is how the data is allocated, the memory is allocated among the various applications. These boundary marks the upper limit of the address is available to each. Actually boundary is the upper limit of the address, okay. So plus 1 means starting from the next space. Alright Ji, then is the security management is another part of the operating system. What is in it? The main responsibility of the security management is to ensure the integrity, confidentiality and the availability of the data. So the data is correct, the data is only accessible to the authorized persons, and the data is available whenever it is required. Alright. So carrying out operating system update, how it can be achieved, these three things, these are important: integrity, confidentiality and availability of data. How these three things can be achieved? It can be achieved by carrying out operating system updates, and when they become available, ensuring that antivirus software is always up to date, communicating with firewall to check all traffic to and from the computer, making use of privileges to prevent users entering private areas on computers. So that is the restricting the unauthorized access with the help of passwords and IDs. Maintaining access rights for all users, offering the ability of recovering data, that is the backup, helping to prevent illegal intrusions to the computer systems. So this is the security management. Then process management, one very important task of the operating system that let the multitasking. And as I told you that a program, when it is running, it is called a process. Means when it is brought into the RAM from the storage, then the sleeping program, when it is active, it is a process. So process is a program which is being run on the computer. Process management involves the allocation of the resources and permits the sharing and exchange of data. So when a program is loaded into the RAM, it is now active and it requires, it has got the CPU time, and means it will also be allocated various resources, input and output resources. So allowing all processes to be fully synchronized means scheduling of the resources, resolution of the software conflict and use of queues and so on. So the process, it is running and then it is blocked, it is runnable. So actually it starts from runnable, scheduled, and then it is running, and when it waits for resources it will be taken to the blocked, and when the resources are available it will again go back to the running. Running is actually runnable, means this can be written as ready. Pardon me. Ready, runnable is ready. So this is the first, and then this is second, and maybe after the running it can end, it can quit, and while running, if it wait for the resources it will go to the blocked, and once the IO operation is accomplished then it will again bring back into the runnable or ready state. So these are the state, and this is how the process management is done. Hardware management involves all input and output peripheral devices. Basically, the operating system is the one responsible to interact with all the peripherals like the printer, mouse, keyboard, scanners, mic, whatsoever, cameras. So how it interact with these devices with the help of the device drivers. So actually hardware management is the part that is doing this job. It involves input and output peripheral devices. So communicating with all peripheral input and output devices using device drivers, translating data from a file into a format that the IO device can understand, ensuring each hardware resources has a priority so it can be responded by the processor. The management of IO devices is essentially the control and management of the queues and buffers. Okay, so when they are responded, they are given the time by the processor, they are actually placed into the queues. Like when printing out a document, the printer management locate and load the printer driver into the memory, send data to the printer buffer. Buffer is actually the memory held by the hardware. Like if we talk about the printer that receives the printing tasks, and the purpose of that buffer is to manage the difference in the processing speed of the processor and the printer. So the buffer will have the task to accomplish, and there is also a queue in the printer if it has more than one print commands. So they will be arranged in queue in the buffer. If the printer is busy, so it will be in the print queue. So when it is into the buffer, it will be taken and it will start printing. Send various control command to the printer throughout the printing process, receive and handle error messages and interrupt from the printer. And the last one is the file management. File management include defining the file naming convention like the .bat, .htm, .dbf, .text, .docx. It actually, these are the extensions, and they tells the type of the application in which the files they are opened, perform specific tasks such as create, open, close, delete, rename, copy, move, maintaining the directory structure, and ensuring access control mechanism, access rights to the file, password protection, and then specifying the logical file storage format like FAT and TFS, the file allocation table depending on which type of disk formatter is being used, ensuring memory allocation for a file by reading it from the hard disk drive or the SSD, loading it into the memory. So this is all about the operating system and the functions and the responsibility of this operating system. In the next lesson, I will explain the utility softwares and then the other part of this lesson.